So I'm ready now to look at some examples using the disk and the washer method. And so what I wanted to start off with was using an example where I looked at the region bounded by 1 minus 1/2 of x, all of that squared, quantity squared, in the first quadrant revolved around the x-axis. Now notice I underlined the x-axis for you. That's because it's really important. I want to kind of drive this home that it really matters whether we're using the x-axis or the y-axis, because in this case it's going to affect how my shape looks, how my region is. And so in this case, number one says we're going to find the area of the region, and then I'm going to make it the 3D figure and find the volume of the solid. So the first thing I'm going to do is, again, just a review. We're going to find the area of the region under this curve in the first quadrant. So I'm going to go ahead and graph this first. Now hopefully you realize if you plugged in 0, you're going to get 1, because 1/2 of 0 is 0, squared is 0, 1 minus 0 is 1. Let's keep going. If I plugged in 1, I'm going to do 1/2 of 1, which is 1/2. I'm going to square that and get 1/4, and then I'm going to subtract that by 1 and get 0.75. So at 1, it's still at 3/4, 0.75. If I plugged in 2, 1/2 of 2 is 1, 1 squared is 1, and 1 minus 1 is 0. So that's going to be the x-intercept. That's going to be where this graph kind of disappears. Now, if you wanted to, and I probably would recommend it, I'm going to go ahead and just plug in 0.5 since it's on my graph, just to see where it is. 1 minus 1/2 of 0.5 squared gives me 15 over 16, which is 0.9375. So it's still pretty high up here. It's going to be a pretty, I'll call it a wide parabola, and I'll go ahead and plug in 1.5, and I got 7 over 16, which is 0.4375. So it's a little bit under a half. So my parabola is going to look something like this. Okay. Now that I've got that graphed, like I said, what we're looking for first is the area underneath this curve in the first quadrant, so here. So notice again, we're still using x as 0 and x as 2. Once I've got that, I'm going to go ahead and start working on my integration. So we're going to go from 0 to 2 of 1 minus 1/2 of x squared dx. Okay, so I probably want to go ahead and do the squared part on that just to make my life easy. So from 0 to 2 of 1 minus 1/2 squared is 1/4. X squared is x squared. There's my dx. So I'm going to go ahead and work on integrating this. That's going to become 1x minus, if I divide by 2, that's going to become 1. I have to divide by 3. My apologies. Divide by 3 because it's x cubed, so it's 1/12 of x cubed. And we're integrating from 0 to 2. Okay? So if I plug in 2 first, I'm going to do 1 times 2 minus 1/12 times 2 cubed. And then I'm going to subtract 1 times 0 minus 1/12 times 0 cubed. Hopefully you guys realize that's just going to be 0, so I don't have to worry about it. So I'm going to worry about this. 2 minus 2 cubed is 8. And I'm going to do 8 over 12, which should be, let me just double check just to be sure. 8 over 12 should be 2/3, okay? All right. 2 is going to be 6/3 minus 2/3 makes 4/3. Whoop. Which you could also write as 1.3 repeating. Okay, so that's my area, is either 4/3 or 1.3 repeating. I usually leave it as fractions just because that makes my life easier. So now that I found the area of the curve, what I'm going to go ahead and do is try to figure out the volume of the solid. So here's the thing. If I am rotating this around the x-axis, what's going to happen is I'm going to have a very similar looking curve down here on the bottom. It's just rotated. It's still the same kind of parabola. It's just now on the bottom. And so what this is going to look like is pretty much like a bowl. It's just not going to be hollowed out in the middle. It's just one solid continuous piece. And so if I were to look at a slice of it, it's a solid slice. And so that makes this the disk method. So I'm going to go ahead and write up my disk method over here. We did pi r squared from a to b. Well, again, still using x's, so we're still going from 0 to 2. I'm going to go ahead and stick my pi in. And the thing is my radius of this disk is just my blue line, which is y minus 1/2 of x squared. But remember, we're going to have to square that again. So we're taking this whole y part and squaring it. Okay? So I'm going to write it over here. 1 minus 1/2 of x squared to the squared dx. Okay? Let me repeat that again. We're taking this function this y equals 1 minus 1/2 of x squared, and I'm squaring it because that's the radius. So I'm going to go ahead and rewrite that again, and I'm also going to go ahead and pull out the pi. So I'm going to have the pi on the outside, 0 to 2, 1 minus 1/4 of x squared squared. I'm going to go ahead and multiply that just so I can go ahead and do it. So 1 minus 1/4 of x squared times 1 minus 1/4 of x squared. 1 times 1 makes 1. That's going to make negative 1/4 of x squared minus 1/4 of x squared. When I multiply those together, I'm going to get positive 1 over 16 x to the 4th, because I did 1 times 1, 4 times 4, and x squared times x squared. Those middle things are going to combine, so we're going to do 1 minus 1/2 of x squared plus 1/16 x to the 4th. So that's actually what I'm integrating. Don't forget your pi out front. That is the common mistake that I do see kids make a lot, is they forget whatever they write out front. They just lose it along the way. I've even been guilty of that in the past. So again, integrating from 0 to 2 of 1 minus 1/2 of x squared plus 1/16 x to the 4th dx. We're going to go ahead and try to integrate. Don't forget your pi. 1x minus, I'm going to make that x cubed, so I'm going to divide by 3, which makes 1/6. That's going to become x to the 5th, so I'm going to have to multiply 16 times 5, which I want to say should be somewhere around 1 over, I think it should be 80. I'm going to double check just to be sure. 16 times 5. Yeah, 80. All right, then I'm going to go ahead and again, we're going to do 0 to 2. I'm not even going to worry about the 0 because all that stuff's just going to end up being 0. So it's going to be pi times 1 times 2 minus 1/6 times 2 cubed plus 1/80 times 2 to the 5th. All right, I'm going to just type all that in the calculator and hopefully it'll give me a nice pretty answer. So 1 times 2 minus 1/6 times 2 to the 3rd plus 1/80 times 2 to the 5th, which gives me 16 over 15, and can't forget my pi. So that is going to be my final answer, 16 over 15 times pi, or 16 pi over 15, however you want to write it. But again, hopefully that does help explain to you what is going on here. Notice again, it's still very similar to doing the area formula. It's just we're now adding an extra step. We're doing the pi, and then we're doing the square. All right, I'm going to come back and do some more examples in just a minute.